we're going to evaluate absolute value functions, the limits of absolute value functions now. And this gets a little bit tricky because remember, when we're talking about absolute value, do you guys remember what that means? Distance or distance from zero. Well, if the absolute value of x is 5 spaces, well, that could be 5 because the distance from 0 is 5 spaces. Well, it could be 5 or the negative version. So when you have these absolute value limits, you have to set up 2 different limit situations. So look at what we have below. We have the limit as x approaches 0, x plus the positive if this was the absolute value of 2x, and we have the limit as x approaches 0 if it would have been a negative 2x on the inside. And remember, you just remove the absolute value bars. So then, as you're doing that, go ahead and simplify, because x plus 2x is 3x. X subtract 2x is negative x. And now you can go ahead and evaluate. But typically, what helps is if you do this graphically also. So the function y equals 3x, whoops, let me get rid of this, is this graph right here. And then the function y is equal to negative x, so think about that. Y is equal to negative 1x plus 0. That's the same thing as negative x. The 0 is just invisible. That graph, although they don't need to be dashed lines, is going to look something like that. In fact, let me make these solid lines so you... And as you can see, in evaluate the limit, as you're getting really close to 0, from the left and from the right, you end up there at 0. So let's see if yep, and then here's the answer for that. So now, yes, I realize you already saw the answer for the next one, but let's go ahead and look at it anyway, and I'm going to cover up all this stuff so we're not distracted. So now you've got this absolute value limit. Well, again, remember, when you have absolute value bars, you have 2 different limit situations going on. You have the limit as x approaches negative 3 times the quantity, the positive version, the positive side of the number line, x plus 3, and then over the quantity x plus 3. Or you have the limit as x approaches negative 3 times, then the negative side, this side over here, negative x subtract 3 over the quantity x plus 3. Well, if you notice on this equation, this limit right here, well, any number, any quantity over itself cancels. And then when you evaluate the limit, you just have equals to 3. And with a whole right there. Well, when you have, remember, when you have the limit as x approaches negative 3, 3, that's just going to be a horizontal line at 3. But remember, so if we look at negative 3 and we go up, there has to be a hole right there, because down here in the denominator, even though they cancel out, when x is equal to negative 3, wherever that graph is, line is graphed, there will be a hole at negative 3. All right, so now we've got the right side to look at. Well, what do you notice about negative x and negative 3? We can factor out a negative 1, and when we do that, negative 1 times 3 is negative 3. Now those will cancel. Still, there will be a hole where x is equal to negative 3. But now look at what? There will be a horizontal line at negative 3. So down here, let me go ahead. Whoops, did not mean to do that. This is just negative 3 right here. So down here at negative 3, there will also be a hole. And then we can go ahead. This is what most absolute value graphs look like. The ones that are set up like this are going to look similar to this. And then the ones that are set up like number 9, the graphs will look similar to that. So just, if you need to rewatch this, go ahead and do that. We'll practice these in class.